Section 2.5 is on converting mixed numbers and improper fractions. Oftentimes with fractions, it's best to remember what fractions even mean. And the one thing that I can tell you that is most important is to remember that this denominator means the number of equal parts. So 3 1/4 means that whatever it is that you have, it's all divided into 4 equal parts. So this means that I have 3 wholes split into 4 equal parts. And then I also have another 4th. And when you first started learning about fractions, your teachers probably told you about shaded parts. Well, 3 wholes means there's 1 whole, 2 wholes, 3 wholes, and then 1 extra 4th. So one of those 4ths. One improper fraction would mean we're not talking in terms of wholes. We want to know how many 4ths there are total. Well, if you look, here's 1, 2, 3, 4 4ths, which is 1 whole. There would be 5, 6, 7, 8, 9, 10, 11, 12, and then 1 more over here would make 13. So that is a total of 13 4ths. Looking at my picture. Well, the shortcut to doing this, instead of drawing pictures, would be using the shortcut. And the shortcut of this, I'm going to get rid of this arrow here. The shortcut of turning mixed numbers into improper fractions is to multiply your denominator by your whole number. So 4 times 3 is 12, and then you add that extra numerator on top. So 4 times 3 is 12, plus 1 is 13, and your denominator always stays the same because, again, we're talking about the number of equal parts. So 3 1/4 is equivalent to 13 4ths. Here are 2 more examples of converting mixed numbers to improper fractions. First thing you do is multiply your denominator by your whole number. 8 times 5 is 40. Add your numerator, plus 3 would be 43. And your denominator always stays the same, so 43/8. The second example on this slide would be 10 and 11/12. Again, you multiply your denominator by your whole number. 12 times 10 is 120, plus 11, sorry. So 120 plus 11 would be 131, all over 12. Now take a look at this exact same problem that we did before. This time, think of it in terms of your mixed number first. If you were starting with 13 4ths, which you see in the picture, you could see that instead of just counting 13 4ths, you could look at it as here is a whole, here is a whole, here is a whole. So total you have 3 wholes. And then you've got this 1 extra 4th over here, which is 1/4. So that would be 3 1/4. The math behind this would be taking this 3 4ths and asking yourself, well, how many 4ths do I get out of 13? Well, you get 3, because 4 can go into 13 3 times, which gives you a total of 12, which means that you have 1 left over. That goes on the top, and again, your denominator always stays the same. 2 last examples. If you start with an improper fraction, it's basically just division, because fraction just means to divide. So you do 16 divided by 3, or how many times can 3 go into 16 without going over? 3 goes into 16 5 times, and that gives you 15, which means that you have 1 left over, so that would be 5 1/3. You don't have to simplify that because 1/3 is already in simplest form. If you look at the next one, 44/8, ask yourself, how many times can 8 go into 44 without going over? That's 5 times, which is 40, which means that you have 4 left over. Again, your denominator stays the same. However, once you get to this point, you might look and realize, oh, 4/8. That's not a fraction in simplest form. So then you go through and look what you can divide both of those by, which is 4. So if you divide both of those by 4, don't forget your whole number, please, but then 5 divided by 4 is 1, and 8 divided by 4 is 2. So your final fraction in simplest form would be 5 1/2.